Hey guys, I hope you're doing well. Today we're going to talk about triangle classification, and there's so many different ways that you can classify triangles, but we're just going to touch on 6 here that are probably the most common and probably the ones you're going to want to see, that you will see, on your tests and quizzes and things like that. So it's important to note before I get into them that triangles can, and they usually do, fall into one or more of these categories. So just because it is scalene, for example, does not mean it's not a right triangle. It's not acute or something like that. It can be. So let's get into them. So first, the right triangle. Any triangle that has a right angle inside of it is a right triangle. That one's pretty simple. If you have a 90-degree angle, a right angle, you're a right triangle. Next is the acute. Remember that acute angles are between 0 degrees and 90 degrees. And if you have a triangle in which all the angles are acute, so all of them are between 0 and 90, not equal to 90 because that would make it a right triangle. But if they're all acute angles, you have an acute triangle. And then the obtuse triangle is if any one angle in the triangle is obtuse, meaning it's between 90 degrees and 180 degrees, then you have an obtuse triangle. And remember that only one angle could be obtuse in a triangle because the total angles need to add up to 180 and obtuse angles are greater than 90. So if you have 2 obtuse angles, then you're already over 180. So you can only have one obtuse angle in a triangle. So if it has an obtuse angle, it's an obtuse triangle. So those 3 classifications based on the angles are pretty simple. So this is, I'll just mark these 3 off. This is your angle classification. So you'll often want to classify the triangle based on the angles first, and then you can get into the other classification, which is based more on side length. So this is primarily side length classification. And so most triangles that you see, all of the triangles will have classifications in both, but some of them you won't have enough information to declare if the side length classification or maybe not the angle classification. And we'll go through examples and you'll understand what I'm talking about a little bit better. But let's start with scalene. So this is a triangle in which no side lengths are congruent. So every side length is unique. And please be aware that if all the angle measurements are different, that implies that the side lengths are different. So a triangle that has 3 different angle measurements will be scalene because the angle measurements correspond with their side lengths. So what I mean by that is that a 100-degree angle, the side length across from it will be greater than a 30-degree angle side length. So that's an important thing to know. Next is the isosceles triangle. And this is a triangle in which 2 sides and their corresponding angles are congruent. So basically, if 2 sides are congruent, then you have an isosceles triangle. Lastly, the equilateral. This is one of the most basic. If all the sides are congruent, then it's an equilateral triangle. Equilateral, equal. So that's a pretty easy one to remember. And all angles, if you have an equilateral triangle, all the angles must be 60 degrees because 180 divided by 3 is 60. So they're all equal at 60 degrees. So let's get into some practice and see how this actually works. So classify the following triangles. Example 1, we're given a triangle with 3 unique side lengths. They're all different and it has a right angle. So immediately I see the right angle. I'm going to say right triangle. So right triangle, that one's pretty easy. That's my angle classification. Can I do a side length classification? Yes, I can. They're all unique. So I have a scalene. They're all different lengths, and that is the definition of a scalene triangle. So those are my 2 classifications that I get from this one. Let's go to the next one. All we're given is we're given a triangle and we see 2 dashes. So now you need to know what these dashes mean. I'll write that out here. So dashes imply congruence. So dashes imply congruence. So if those 2 lines have dashes, we can assume they're congruent, which means equal in length, equal in measure. So if I have 2 side lengths that are equal in measure, then I must have an isosceles triangle because the definition of isosceles was when 2 angles are the same measure or 2 side lengths are the same measure. So it's an isosceles triangle, not triangles. And now the second question is, can I classify it by angle? You can't look at it and say it's an acute triangle because we don't know for sure. That's something that a lot of people like to do. They can say, oh, it's clearly an acute triangle based on how it looks. Just don't get into that habit because sometimes teachers will be like, oh, well, you can't tell for sure just based on the things we give you. So you don't classify it as acute for that reason. But is there any way to look at it and tell that it's acute? there's actually nothing that we know. Just because we see that two sides are congruent, we can't assume it is an acute triangle. This angle on the top, this one, could be an obtuse. So that's the reason we can't say it's acute. All we can say is that it's isosceles. We cannot classify. It could also be a right angle. So this one could be obtuse or right. So no classification based on angle. All right, next we're given 3 angle measurements. They're all different. So that means the side lengths are going to be all different because, like I said earlier, the side lengths correspond to angle measurements. So if all side lengths are different, I have a scalene. I see that first. And then now I can look at the side lengths. Well, are they all less than 90? Yes, they are. So that means I have an acute. So it's a scalene and acute triangle. So this one, we were able to get both of our classifications in there. So scalene acute triangle. I'm not very good at drawing circles with this yet. Hopefully I'll get better. So next, we're given a triangle and one angle. Clearly it's an obtuse angle, 120 degrees. So the first thing I'm going to write is it's an obtuse triangle. So I've done my angle classification. So now the next question is, can I do a side length classification? Well, no, I can't because I don't know if these two sides are congruent or not. There's no marking. So you could kind of assume they're not. So if you did that, you could say that it's probably a scalene. You could probably say that it doesn't have any, but it's a little iffy because what I'm saying is that if it had this, we would know it was isosceles, right? But it doesn't have that. So the question is, can we assume that they are different? And you'd have to ask your teacher. I would assume that they were different, so I would say it's a scalene as well. But some teachers may not label that and want you to just say it's an obtuse, but I would say it's an obtuse scalene. So obtuse scalene, again, my circle is not very good, and also I wrote scalene very bad, but all right, final example. We just have a triangle. We have three of these dashes. Remember, like I said earlier, that implies congruence. So if all 3 sides are congruent, that means we have an equilateral. And when we say equilateral, we know that all the side lengths, the angle measurements, are 60 degrees. I'll write that in here. So that means every one is 60. But the thing is, with equilateral, it's a little different. I guess you could write it as acute. So it is an acute triangle. But most people imply that when you say it's equilateral. When you say something's equilateral, everyone knows that all the side lengths are equal and all the angle measurements are 60. So saying it's also acute is a little beside the point because we already know that it's acute because it's equilateral. So just ask your teacher what they want you to say for that. But if a triangle is equilateral, it is by definition acute as well. So you might not have to put both of those. But hopefully this makes sense. Hopefully you kind of understand the different ways you can classify triangles now. I would recommend studying this a little bit as much as you can. And let me know if you have any questions. Thanks for watching.